Okay, okay, good morning. So, 17 students, 19 now it is, number is getting increased. And today we'll discuss Avalanche Photodiode, very important one. Okay, and I think you are able to get my voice clearly. And if you have any doubts in between, you can write in comment section, or you can personally WhatsApp the doubts. I think your voice recording also you can submit. And are you able to get my voice clearly? Or is it audible? Okay. So it seems you are able to listen clearly. Yes. So in this, okay, good. So in this critical situation, Corona situation, COVID-19, I'm due to some other security reasons using other video um, applications, Zoom, वगैरह. So I have switched to this YouTube Live, and in my because no other stationary other things are not available outside. This is the setup I use. Okay, adjust with this. Today we'll discuss photodiode about photodiode and Avalanche photodiode. That is we are going to discuss. Okay, and are you able to see that writing clearly? Is it visible? Okay, let us see. Let us basically will see the main application of photodiode, Avalanche photodiode. It is used as photo detector. Okay, and photo detector has many applications in sensing devices, in alarm devices, in door opening supermarket, door opening devices, automatic door opening devices, counting devices. Many applications are there. The main principle in this photo detection is it converts incident photon, that is light, into electrical energy. This is the basic principle. And PIN diode is there. That is also photodetector. And this is avalanche photodiode. We'll discuss the differences. Few differences are there at the next class. And one more phenomena, one more device is there, solar cell. That is also converts photo energy or optical energy into electrical energy. This is also converts optical energy into electrical energy. So, what is the difference? In a single sentence, the photodiode is a photoconductive cell, photoconductive in nature, whereas solar cell is photovoltaic. Is it clear? Photovoltaic. Here we connect a battery across it. We apply potential difference. In case of solar cell, we don't apply. When light is incident on the alkali metal, gives out electrons, we see the current in the circuit. You know that you perform that experiment in the lab. Okay, so the basic few things we'll discuss. Few points if you get clarity, remaining whatever the notes you have with you, and whatever things we are going to discuss, you can understand clearly. So, what is the basic phenomena in photodiode? What is the basic principle? What materials we use in this? What is the functioning? Okay, these things we'll discuss. What is the construction and electric field profile? These things we'll discuss. Now, already as we discussed, the main intention of main application of photodetector is its convert main principle of photodetector is converts optical energy into electrical energy, right? So, in case of avalanche photodiode, the low intensity optical signals it has to detect. Actually, it is designed to detect a low intensity light signals. Okay, and so low intensity signals in the sense what low intensity of light, how you have to convert it, what measures we have to has to be taken, how this material choosing of materials. Basically, in photodiode, in this avalanche photodiode or any photodiodes, we use semiconductor materials, right? And what is our intention? Detecting low intensity light. Now the question is, you can use your basic physics formula, physics knowledge. If you want to detect a low intensity light, low intensity optical signals, when you use semiconductor materials, because semiconductor materials are only we have to use because germanium, silicon, third to fifth group combinations alloys we take so that we can get required energy gaps. Okay, so here if you want to detect low intensity light, low intensity optical signal, you have to choose a semiconductor material. And the question for you is, what should be the energy gap? Is it less lower energy gaps or higher energy gaps? Okay, in between, as in previous class we stopped at direct and indirect that we discussed. Remaining non-radiative recombinations we did not discuss. After completion of PIN, we'll discuss it. Okay. Anyway, after completion of Unit 3, we'll go to revising Unit 1, Unit 2. Then next sessions will continue by balance. Okay. So here my question is, you can answer in the comment section. I'm able to see. The question is, if you want to detect low intensity light, right? What should be the energy gap, choice of energy gap? It should be low or higher. You should have lower energy gap semiconductor materials there. Combination alloys we take. Finally, what should be there? Lower energy gaps or higher energy gaps? Question 2. So if you think lower energy gap, because nobody answer it. If you think lower energy gap, you're unable to answer it. Lower energy gap is the perfect choice. You should have smaller energy gap semiconductor combinations you have to take in this photo diagram. If larger energy gaps are taken to make electrons move from one region to other region to cross this energy gap, you have to supply more energies. It is of no use. Okay, this is the one thing. Now, basic principle and what material semiconductor has to be taken, and another condition is the energy gap should be less. That is also one important point we noted down. Now, of course, we are taking energy gap. Okay, we are taking energy gap, lower energy gap, semiconductors we are taking. Now, one more question. What is the question is, when semiconductor is taken, we connect battery bias. Two types of biases are there: forward bias and reverse bias. Right. What should be the bias? You don't refer any notes or anything with you. Just try to think. If you refer the notes, what? No, there is no use of answering it. Okay, because it is live session. If you can answer it, okay. Otherwise, I will tell the answer in the notes. Also, answer is there. If you question and if you answer, try to answer it, you can remember in throughout your lifetime. Okay. The question is, second question is, it is the semiconductor material. If you want to apply bias, forward and reverse among these two, which type of bias you should apply? You can answer. Two biases are there, forward bias and reverse bias. Which bias? If your answer is reverse bias, exactly. Now we'll see, if you connect in forward bias, what is main intention of photodiode preparation of Avalanche photodiode is it has to detect low intensity light. Clear? Low intensity light. What happens when this low intensity light incident on, I will show a picture. This, okay, low intensity light incident on it. When low intensity light incident on it, electron hole generation takes place. This electron hole generation, because we applied the bias across it, this electron hole generation, the electrons and holes move away in the respective directions. That flow of electron you can see in the circuit as current flow. Okay, this the use of it is different. We'll see later. So when photon is incident on photodiode, electron hole pair is formed that traveling, that you can see, that you can see in the circuit. Okay, as current flow. See in the forward bias. See here, when current flow is taken place in the circuit, we can say that there is some current, some optical signal is there. We are detecting it. Optical signal we are detecting. When optical signal is incident, current flow takes place. So at front end, at user end, we will be there. We don't see what is happening inside it. We are seeing whether current flow is there, deflection is there or not. Oh yes, deflection is there. If deflection is there, in the sense what? Light is incident on it. So it is detected light. Clear. Now, if you connect in forward bias, what happens you think? Whether light incident or not, if you connect it in forward bias, the flow of electrons takes place in the circuit, current flow will be there. Yes. So that is the reason when you connect this PN diode in reverse bias, it is in switch off mode, no uh, flow due to charge carriers, majority charge carriers will be there, because we apply reverse bias different combinations. Those minority charge carriers flow also can be minimized. So only what is the possibility when photo incident on it, electron holes will be generated, current flow takes place. Photon incidence causes current flow. So at front end current flow we have seen. That means what? Photo is incident on it. Optical signal is incident on it. Clear, right? Now we'll see. So here till now, few important points we have discussed. What is the main principle? What is the application? What is main principle? And what should be the energy gap? And what is the bias? Which bias has to be applied? Right. Now we'll see the construction. In construction part, we will have, so in construction part, okay. So here this region is doped with p-type material, and this region is doped with n-type material. Right? Clear? And this region of, see in the in the previous diagram I have shown it here. This is plus, this is N, this is I have drawn in opposite direction. Anyway, no problem. This is P, this is N. P plus and P N plus. N plus in the sense heavily doped um, N type. And next is P, and this is I region or pi region, intrinsic region, or it is called pi region. Pi region. Right? I region or pi region. This is N plus heavily doped. This is P plus heavily doped positive, and this is P. Here you have a PN diode, right? And in this case, at junction, because we have applied a uh, reverse bias, at this junction, what happens is larger. That is, it is connected in reverse bias. This region, okay, plus in the sense n plus to that n plus we are connecting to higher voltage. That means what? Larger potential drop, reverse bias, larger electric field is present in this region. Clear? And this is intrinsic region or pi region. This is P plus O. Now, when light is made to incident on it, when photon is made to incident on it, then what happens is electron and hole pair, electron hole pairs will be created. So, where in which direction electron will move? Because it is positively here, higher potential is connected. Electron move in this direction and hole move in this direction. This electron moves to here in this region, and this region has higher electric field. Clear? Due to that higher electric field, these electrons or get accelerated, and these electrons collide with other electrons and collide with atoms over there. Clear? Collide with electrons and collide with atoms. When this electron collide with atom, again this electron removes a electron from that atom. That is ionization takes place. This due to this many number of collisions, again that electron collides with lattice atoms and collides with other electrons. Due to this many collisions, elastic collisions, more number of electron holes pairs will be generated at this region, and that causes electric flow in the circuit. This phenomenon here, due to collisions, what is happening? Due to collisions, more amplification of electron hole pairs are taking place. That phenomenon is called impact ionization. This impact ionization is important in this. Whereas in PIN diode, you won't get impact ionization. And one more important, when you apply bias, how much value has to be applied is we apply um, uh, up to breakdown voltages. There, you know what is breakdown voltage. At breakdown voltages, we apply. For the application of breakdown voltages, the charge carriers will have saturating velocities. The velocity, they move with saturation velocities, maximum velocity, saturation velocities. And whatever the field here in the PN region is there, it is maximum, higher electric field. These saturated electrons enters into that region, they move with maximum velocities, they collide with lattice, atoms, everything collide with different electrons. When it is collided with atom, from that atom an electron will come out, ionization. Like that, many number of electron hole pairs will be formed. So that amplification phenomena is known as impact ionization. I will show the diagram. Previously, I have shown it. See, are you able to see what is happening at pi region? Okay, the light is incident at the pi region. Okay, see, this region. Let me, now it is clear. Okay, so now see, this is the intrinsic region, same region. When photon is incident on the intrinsic region, here electron hole pair is formed. Here. And then hole is moving towards lower potential direction, negative side, and electron is moving towards higher potential, plus side. When this electron moves, due to colliding with other electrons, due to colliding with lattice, ionization takes place. That is, more number of electrons will be developed. And these emitted electrons, again they collide with other part of the lattice. Again, more number of electrons. Like multiplication takes place. Okay, multiplication of electron hole pairs takes place. In this region, because higher potential is present, they, they move with higher velocities, saturation velocities, because we applied breakdown voltage. Finally, we can see electric flow in the circuit. Okay, this is called impact ionization. This is very important phenomenon. That's why avalanche takes place. Is it clear? This is the main basic phenomena in photodiode. Like that, it will be detected. We'll see electric field profile here in this region. You draw electric field profile. Are you able to see? Okay. Now see, in this region, in the bias region, in the forbidden region, more higher electric field or electric field is present. So here gaining is more. This is absorption region. This total is absorption region. This is gain region. Here more number of electrons, amplification of electrons takes place. So it is gain. Okay, it is gain region. This is absorption region. Right. So this is what happens uh, photodiode, avalanche photodiode mainly. Any doubts in this? If you have any doubts, you can ask me. Okay. If you have any doubt, somebody asking, what is the doubt? Ranjit, what is the doubt, Ranjit? Okay. If you have any doubts, you can WhatsApp me or you can chat here. Maybe I think some delay is there here and at receiving end. It seems some delay is there because many of you answering after I disclose the answer. When after answering the question, you are answering, it's a delay is there. You will be there. Definitely will be there. So if you have any doubts, you can ask in WhatsApp also. Okay, some of you have technical problems because internet. So you have to purchase little more data. If you don't have any cable this thing, if you depend on mobile network, I think you have to purchase little more. And of course, this video will be saved in the channel. You can see afterwards. If you have any doubts, you can ask. If you have doubts, ask me in WhatsApp. There is no problem. Okay. So we have only 35 students. We need more. Out of 60, only 35 are attended. Okay, you tell your friends. Maybe some technical problems are there. Actually, I thought to use that Zoom, but due to many, and government also given some suggestions on security purpose. Anyway, we can use it now. Take the notes. If you have any doubts, you can ask me. In in photo generated carriers in the depletion region travel at their saturation velocities, and if they acquire enough energy from the field during such transit, an ionizing collision with the lattice occurs. Okay, ionizing collision in the sense that what you have to be familiar with the words. Ionizing collision in the sense when electron collides with atom or lattice, the atom is get ionized. It gives out electron. This is ionizing collision. Okay, and the field necessary to produce an ionizing collision is in the range of 10 power 4 to 10 power 5 volt per centimeter. Breakdown voltages. So it depends, that value depends on the material. And secondary electron hole pairs. Here secondary electron hole pairs is mentioned in the notes. If you see secondary hole electron hole pairs in the sense when photon is incident on the material, whatever the electron hole pair is generated is primer. These electron hole pairs are moving towards PN junction, and there they hit the atoms. They collide with the atoms. Due to that ionization, electrons are generated. Those are the secondary electron hole pairs. Okay. So after that, see what happens. One of the student asked the question. Here, after generating many electron hole pairs, what happens? What they are driven towards the this end, high electrode end. So current flow takes place in the circuit. Electrons move and the current flow takes place. That's what we need, right? And the process is known as impact ionization. Now, one more important point in this, the multiplication factor of Avalanche photodiode. The multiplication factor, you can write M equal to I by IP. This is multiplication factor. I is the total output current at the operating voltage, and IP is the initial or primary photo current before applying this. Okay, M is the measure of the. So if you know M, what is the internal gain, we can understand. Okay, so this is today's topic, and after taking the feedback from you, whether it is clear or not, whether you're able to see watch it continuously or not. See, the main advantage of this YouTube live is if you are unable to watch now due to some technical problems or due to interruption, if you are unable to, if there is a problem in streaming, you can watch it later. Video will be there. Okay, and you raise the doubts if you have any, you can comment section or you can call me personally, you can chat me on WhatsApp. It will be okay, right? And tomorrow we'll discuss two topics, PIN diode and the remaining topic, recombination. Actually, we'll have 1 hour class, 40 minutes to 1 hour class daily. 40 minutes will limit to maximum 1 or 2 topics. And the if you have any doubts in today's session, you ask me, raise me, and in the next class tomorrow, in the tomorrow class, first we'll discuss those. After clearing those doubts, we'll go to the next topics. Okay, and one more important point in this COVID pandemic situations, be at home, be safe. Okay, be at home. How can you protect this country is being at home, staying at home. And you can read good books, you can read personality development books, you can read Swami Vivekananda books, you can read your textbooks, if possible. And spend much time with your parents. You ask their childhood days, how they studied at school, who impressed them, which teacher impressed them a lot. And if you have grandparents at home, and you can ask more things at the time, what happened, some plague has, at how they face it. You can spend very good time with your parents. At the same time, being CSC students, you try to know, try to learn new things, try to know what is present um, in terms of software, or what is happening in the present day, the technical side, and try to learn writing CV curriculum material. Many YouTube videos are there. You just give a trial for them till after before because you have enough time. If you have practice of preparing CV, finally you can create a very good CV, and who just by seeing your CV, they will get impressed. Maybe get very good offer, 20 lakhs per annum. Hope so. Okay. Anyway, all the best. Tomorrow we'll continue with another topic, PIN diode, and also remaining topic in this um non-radiative recombination process. Good luck.